Alright, so with this special setup, let's say that we've got a focal point for lens 1 that's located 20 centimeters away from the lens, let's say. So we got F1 and F1. And let's say that lens 2 has a focal length of half that. So its focal length is 10. What that means is the focal points will coincide with this setup. So we see here that the lens separation is equal to the sum of the focal lengths. It's a special type of setup called an afocal system. And it's used a lot in like simple telescopes. So imagine you have an object at infinity. Then what would happen? Well, if you do the construction, send a ray in toward lens 1 from infinity, then what ends up happening is that ray is going to bend through the common focal point. But any ray that bends through the focal point of lens 2 is going to come out parallel as well. Yeah, so what does it end up doing? It ends up making a narrower beam. And so this one has a focal length of 20, and this one has a focal length of 10. And let's say you're looking this way at the system. What it ends up doing is, to your eye, it'll enlarge the scene. When you look through a small focal length lens, it's called in a telescope the eyepiece. And this one would be called the objective lens. You might think it would be the opposite, right? Because the beam is narrower, you'd think it makes things look small, but actually it actually enlarges them to your eye. Now you can draw more rays than just these as well. The rays have to come in parallel though, because the object is infinitely far away. This ray will go through the focal point, and it will come out on the other side like so. And we could even draw one parallel to the principal axis. An afocal system because it never really converges to an image.